Hello guys, so we are going to continue the discussion with respect to linear algebra, and in this video we are going to discuss about the addition of two vectors. So in short, now we are going to move towards mathematical operations that we can specifically apply on vectors. Already in our previous video we have discussed like how we can actually represent a vector, let's say in 2 dimension, 3 dimension, and it can be any number of dimensions in short, right? And we are also seeing the application with respect to data science. Now let's go ahead and understand about how do you add two vectors, and with respect to the coordinate system, what does this actually mean? Other than that, I will also be showing you exactly where we will be specifically adding this kind of vectors for use cases in data science also. So let's consider that I'm going to represent my vector P1. And this is, and again, just to show you in a 2 dimension, I'm just going to consider points with respect to 2 dimension. Let's say that I'm going to use points like -4, and this will be 3. Okay. And there is another vector which will again be represented in this dimension. Let's say that here I have like 5, 6. Okay. So these are the two vectors that we have. Now I need to probably perform an operation of an addition, P1 plus P2. That basically means we will take this 2 dimension vector, which is P1 minus 4, 3, and then we will go ahead and add with another vector, which is nothing but 5, 6. So let's go ahead and see this out and check like how things will specifically work. And whenever we say that we are basically adding this particular vector, what will happen is that with respect to the x coordinate, whatever is the numbers over there, we are just going to add those numbers. So -4 plus 5 is just going to give you 1, and 3 plus 6 is nothing but it is going to give you 9. Okay. Now let's go ahead and see this in the coordinate system. What does this look like? Okay. So since this is a 2 dimension, I'm just going to make this coordinate system of x and y. Okay. So here I have 1, 2, 3, 4, 5, 6. Okay. Now in y I have to go till 9, so let me keep this line longer, and here I'm just going to go ahead and write 1, 2, 3, 4, 6. Let's take this as another number. Okay, instead of writing 5 with 6, I will go ahead and write 5 with 3. So that whenever we try to do the addition over here, okay, I'm just going to keep this number 3, and here also we will go ahead and write 6. Okay. Now, what does actually adding this number basically specify? Okay, and let me do one thing. Let me just extend this line so that we will also have the negative values, and here also we'll have the negative values. So here I will be having -1, -2, -3, -4. Similarly, here I'll be having -1, -2, -3, -4, -5. Now, when we talk about this coordinate, let's consider -4, 3. -4, 3 basically means we have to probably move towards this position, and from this point we will go towards the third position over here in the y-axis. This is my y-axis. So let's say this is my position over here, right? And this coordinate is basically given by -4, 3. So if I probably go ahead and draw this vector, it will be in this direction, and the origin will be from 0. Okay. Now, similarly, let us go ahead and draw this particular point also, where we'll just mark this particular point. It is nothing but 5, 3. So 5, 3 basically means I have to probably go on to the x-axis, 5 over here, and 3 is somewhere over here, right? So this basically becomes my 5, 3 coordinate, which is nothing but it is this, right? Now you see this, okay? When we add both of them, what we are specifically getting, it is nothing but 1, 6, right? So 1, 6 is nothing but this will be my final output. Here you'll be able to see I'm having 1, and 6 is somewhere here, right? So this will be my new coordinate. It is nothing but it is basically, let me just make this point over here. Oh, okay. This is like this. Okay. So 1, 6 it is. Okay. So this point is nothing but 1, 6, and this coordinate is basically nothing but it is specified in this way. And this is my final output. But just understand what exactly is basically happening. Initially, when we had this coordinate minus 4 comma 3, we are just going to add another coordinate, that is 5 comma 3. I'm saying it can be a coordinate, it can be a vectors over here. Now when we add this particular vector, this is the new position that I'm getting 1 comma 6. Now just imagine if I take this line and if I just move it parallelly from here. Okay, so if I just go ahead and move it parallelly from here, so here you'll be able to see that we are reaching this point, right? And addition is more about like I will be taking this particular line and I will be adding in this specific point, right? From this point I will be moving towards 5 comma 3. It's just like that, right? So that is the reason when you see 3 plus 3 is nothing but 6. So let's see in this way also. From the origin, first of all I went to 4 comma 3. Then from origin I went to minus 4 comma 3. Then from minus 4 comma 3 I will be moving towards the x-axis 5 position, right? So this will be 1 position, 2 position, 3, 4, and this will be 5, right? So once we move towards the 5 position, the next, this was in the x-axis. Then we'll be moving 3 position towards the y-axis. So it is nothing but 1, 2, 3 position towards the y-axis, right? So this is how the movement is. And with respect to this specific movement, what we are basically doing for this particular vector, we are adding 5 comma 3, right? And that is what we are getting our final result. So addition of two vectors is more like how you're traversing from one vector to the other vector, right? Initially I got minus 4 comma 3. Now from minus 4 comma 3 I have to move to other position like 5 comma 3. So that is the thing that I told you, right? So over here, if I take this particular line, if I move it from this particular point, whatever it will be the destination point, that will be my new vector. Okay, and that is about addition of new vectors. Now you can do the same operation for any number of dimensions. Let's say if I have a point which is given by a vector, and this is represented by x1, y1, z1, and let's say if I have my b point which is represented by x2, y2, z2. So if I also perform an operation of a plus b, this is nothing but it is going to give you x1 plus x2. Okay, this is nothing but it is going to give you x1 plus x2, x1 plus x2. This is going to give you y1 plus y2, and the third thing that you're going to get is z1 plus z2. And if I denote this as x1, x3, y3, z3. So this will be my new vectors in short. Okay. So the addition part is very simple. I hope you have also understood with respect to in a simple example. Let's take one more example, okay, just to show you. Let's say one of my vector A is given by minus 2. Let's say it is minus 2 comma 2. Okay, minus 2 or minus 2. Okay, I'll take minus 2 and minus 2. And B is nothing but, let's go ahead and take it as minus 1 and minus 1. Now if I want to add this, so first of all what I will do, in the x-axis I will go to minus 2, and from here I will again go back to minus 2. So this will be my new vector. This will be my initial vector, right, in this direction. Now when we go ahead and add this number minus 1 and minus 1, what is basically going to happen? See, in top of this, if I add minus 1, then what it is going to happen, it is going to go in this position, so it will go to minus 3, right? In the x-axis it is going to go minus 3 because minus 2 minus 1 is minus 3. Then similarly in the y-axis I have to probably go towards minus 3. So this will be my new position where my value will be minus 3 comma minus 3, right? And this is my vector that you will be able to see for this line, right, in this particular direction. This was about understanding about addition of two vectors. Now let's see with respect to data science where exactly we use this techniques. Okay, example. Okay, example with respect to data science. So in one of my previous company, I was solving a use case. Okay, solving a use case. In that use case, we had some sensors, sensor 1, sensor 2. Okay, now this sensor and sensor 1 and sensor 2, this used to give me some readings. Let's say this readings was in 3 dimension, like 3, 5, 7. I used to get the vectors. Similarly from sensor 2, I used to get 2, 4, 6, right? Now while we had to perform EDA and feature engineering, our main task was that whenever we created our final sensor, right, we needed to add all the sensor values that were coming from sensor 1 plus sensor 2. There's just an example that I'm giving, but actually we had somewhere around 100 sensors. Now sensor 1, sensor 2, all these were giving, and like currently here all the values are in 3 dimensions, right? But in the real world scenario we had somewhere around 120 dimensions, because the sensors were giving values with respect to different parameters, like humidity, it can be outside weather conditions, it can be how much heat it was having, all those kind of information. So to finally find out the final sensor reading, we had to probably sum all the values, because there were multiple sensors that was used in the device. So in short, we just add these numbers. Once we add these numbers, just say for this particular sensor we used to get like 5, 9, 13, right? So this kind of operations are definitely there with respect to the vector addition. Okay, so if I talk mainly with respect to the application in data science, when we say that, hey, we are going to use this in EDA and feature engineering, in short, we are using for data aggregation task. Okay, data aggregation task. Second thing, we definitely use this in feature engineering, because any changes that I really need to probably do it in my features or in any of the records in the data set, I have to probably perform feature engineering. Okay, and if I consider more examples, let's take one very good example. In data science, we specifically work in a field which is called as NLP, which is called as natural language processing. Okay, let's consider one of the use case. Okay, let's say I have an e-commerce website. In this e-commerce website, people put reviews of a specific product. Okay, so let's say here I have the text reviews, I can basically say. Let's say that I will have something called as reviews, and here I will say what is the sentiment. Okay, now let's say one of the reviews like the product is really good. The product is good. Now you know that the sentiment is very high over here, so I'll say, hey, by just mentioning it as 1, I'll say, hey, the sentiment is positive. Similarly, if I get another review saying that, hey, the product is good, product is bad, then my sentiment will be 0, because obviously 1 I'm considering it as good and 0 I'm considering it as bad, right? Like that's, you will be having many other reviews. Okay, now if I really need to train a model, okay, if I need to train a model, this model, what it needs to do is that it needs to take this input data, whatever reviews it has, and it is to provide me sentiments. Now understand one thing, this model is nothing but it is a lot of mathematical calculation actually happens inside a model, and model does not understand this text information. So specifically in NLP, what we do is that we convert this text into vectors, right? If I have this 4 words, okay, I may convert this into 4 numerical values, okay, or I may convert it into 5 numerical values or 10 numerical values. So converting text into vectors usually require different techniques, right? One of the technique is one-hot encoding. In NLP, we have this techniques, one-hot encoding. We have something called as TF-IDF. We have something called as bag of words. We have something called as word to vec. So these techniques, what it does is that it converts all the specific words into vectors. Okay. Now when we convert all these words into vectors, so every sentence is represented into some number of vectors, and these vectors are nothing but it are numerical values, and we can specifically use this numerical values and we can train our machine learning models. Okay, for right now you just understand with respect to this. Now let's consider one very good example with respect to converting this text into vectors, which is also called as word embeddings. Okay, word embeddings. Now in this word embeddings, what happens is that, let's say that I have my word which is called as data. Okay, now data, let's say this is my word, I need to convert this into vectors. Let's consider that we can represent this in this vectors. Okay, I'm just considering, okay, we can represent this in this numerical features. This data is represented in this 3-dimension vector. let's consider there is another word which is called as science, data science, science over here. And if I just go ahead and consider the vectors of this, it will be, I'm just considering, okay, let's represent this particular words in this vectors. Now, if I combine data science together, now this entire vector will change. In short, what we'll do is that we will take the vectors of data, we'll take the vectors of science, and we'll add this up. Okay. So if I add this up, 0.2, 0.1, 0.4 plus 0.3, 0.7, 0.2. Okay. So here you'll be able to see that I'm going to get a value as 0.5, 0.8, 0.6. Now, why I'm doing this? I am doing this because at the end of the day, I'm creating this particular vector representing the word data science. Initially, it was data is separately and science is separately, right? So this final vector that you'll be seeing over here is created for the entire word, or it captures the entire word meaning called as data science, and it is with respect to their embeddings, you know. So it represents the context of the entire word data science. So that is what word embedding is more about, you know. But there are a lot different techniques that we specifically use in order to convert this word into vectors. Okay, but we definitely perform a lot of operations similarly like this, right? So one more very good applications that we usually use, right? It is basically called as image processing. Let's say I have a task which converts, let's say most of the colored images that I have, right? So if you see any colored images, they are usually given in this RGB format. Okay. So R is a different channel. So let's consider my red channel over here represented by this vector. Okay. So this is my red channel, you know, because at the end of the day, everything is pixels. Let's say 250, 255, 128 and 0. So let's consider this as an example. Here you can see that I have this RGB image. Okay. And RGB image are nothing but they are specifically pixels. Every frame is divided into many pixels. If I consider this particular image and if I divide this into RGB scale, I will be getting red color frame separately, green color frame separately, and blue color separately. Let's consider that this is my red channel reading. Okay, 255, 128, and the other values that I have is 0. Okay. Similarly, let us go ahead and consider my green channel. So here I will go ahead and write my green channel. I'm just considering, right? And green channel over here also will be of same dimensions. Obviously, this is not of the same dimension. It is of different dimension. But here you can actually see that the pixels is 260 into 194. And the 3 that comes over here is basically talking about how many channels are there. 1, 2, 3. Okay. So if I probably consider this green channel, it is nothing but 128, 255, 0. Okay. And finally, you can also see that I have something called as blue channel. So when I say blue channel, I am basically going to consider it as 64, 64, 255. Okay. Now, if I want to convert this RGB image into a grayscale basically means black and white. That basically means I need to combine all these 3 pixels together. So every 3 pixels I need to combine. So in order to combine, what I can actually do, I can just add it up, right? So here you'll be able to see that for RGB, so we'll take this first value and we'll keep on adding. So it will be 255 plus 128 plus 64. Then next I will be taking up 128 plus 255 plus 64. Then I have 0 plus 0 plus 255, right? And if I probably do the division with respect to 3, since we need to calculate the average, I will be getting 149, and some more value, let's say 254 to 255. So here if I probably go ahead and see, this will be coming up 85. Okay. So this is my final white and black image, right? Which we also say it as grayscale. So at the end of the day, each channel is represented by a vectors, and we can also do the summing up of all these particular vectors in this specific way, right? So this is also heavily used in image processing. So I hope you got an idea what exactly addition of a 2 vector means, and with multiple application, how it can specifically be used even in NLP, text pre-processing, image pre-processing and all. We have discussed about it. So yes, this was it from my side. I will see you all in the next video. Thank you.